In the heart of China's Shandong province, a massive body of water divided the city of Qingdao for centuries.
The solution was audacious, a shortcut that would slash travel time by 30 minutes. But to save those minutes, engineers had to conquer the sea.
The Jiaozhou Bay is not just water. It is a zone of high salinity and severe winter ice.
The plan: a 26.7-kilometer colossal roadway floating above the waves, requiring 450,000 tons of steel, enough to build several Eiffel Towers. It would become one of the longest bridges in the world.
An army of 10,000 workers and a fleet of ships mobilized for war against the elements. Before a single stone could be laid, precision surveying was required in the middle of the shifting ocean. The foundation had to support a structure designed to withstand earthquakes and typhoons.
The project was not just a bridge. It was a 41-kilometer connection project that would change history. A unique T-shaped design connecting Wangdao, Likang, and Hongdao in a single mega structure. But the clock was ticking. 4 years to build the impossible.
Phase 1, the foundation.
The seabed here is soft mud and rock. Traditional foundations would sink.
Engineers utilized bored concrete piles, 5,238 of them to be exact.
First, massive steel casings are driven deep into the ocean floor to create a dry work zone. Precision is key. A deviation of just a few centimeters could compromise the bridge.
Hydraulic hammers drive these steel tubes through layers of sediment. They go deep, anchoring the bridge into the bedrock beneath the mud. Once the casing is set, powerful rotary drills bore out the earth inside. Tons of spoil are removed to make room for the concrete core.
Meanwhile, on land, steel reinforcement cages are prefabricated.
These cages provide the tensile strength needed to resist ocean currents.
Transported by barge to the middle of the bay. Lifting these skeletons requires perfect coordination between crane operators and ground crews.
The cage is slipped into the dark abyss of the casing.
Now comes the concrete. 2.3 million cubic meters were used in total.
Special marine-grade concrete is pumped to the bottom of the pile. This underwater pour pushes water out as the concrete rises. The mix must be perfect to prevent saltwater corrosion from the inside out.
Even in freezing temperatures, the work does not stop.
Day and night, the rhythm continues. Drill, reinforce, pour. Even in freezing temperatures, the work does not stop. These 5,000 piles form the invisible legs of the giant. They stand firm against the tides, ready for the next stage. Quality inspectors verify every inch. Safety is the priority. The foundation is laid.
The path across the bay is emerging. To build the pile caps, watertight cofferdams are lowered. In sinking these steel boxes, workers can build the caps below the waterline. Descending below the surface of the sea, the team ties the piles together. A massive block of steel and concrete, the pile cap, locks the foundation together. This cap distributes the colossal weight of the traffic above. Once cured, the steel form is removed. The cap is complete. Now, the piers begin to rise. This is dangerous work, balancing high above the churning water. Bucket by bucket, the piers grow taller. Hundreds of these columns will support the roadway. The Jiaozhou Bay freezes in winter. The ice pushes against the concrete. The concrete is specially formulated to resist freeze-thaw cycles. Every pier is treated to ensure it lasts for a century. Some sections require V-shaped piers for added stability and aesthetics. An avenue of concrete giants, waiting for their burden.
Logistics are a nightmare. Every ounce of material must arrive by boat.
Navigating heavy ships between these columns requires expert pilots.
The semi-directional T interchange is a marvel on its own.
It is the first oversea interchange of its kind in the world. Shock absorbers are installed. They will dampen the energy of earthquakes. These bearings allow the bridge to flex without breaking. The skeleton is standing. Now, it needs a spine. To speed up construction, the roadway is built on land. These are box girders, prefabricated segments of the highway. Manufactured in a controlled factory environment for maximum strength.
Each segment weighs thousands of tons.
Moving them to the water's edge is a delicate operation.
Enter the heavy lifters, floating cranes with immense power.
This single piece creates 60 meters of bridge instantly. The ship carries the roadway to its final resting place.
The alignment must be perfect.
Using radios and hand signals, workers guide the giant.
A game of millimeters involving tons of concrete.
Touchdown!
Piece by piece, the gap between Qingdao and Wangdao shrinks.
But for the shipping channels, a flat beam isn't enough.
The Qingdao Channel Bridge requires a 260-meter span for ships to pass.
Workers climb higher, building the pylons that will hold the cables.
These towers are the crown jewels of the project.
Steel cables, capable of holding immense tension, are unspooled.
The deck here doesn't sit on piers. It hangs from the sky. Hydraulic jacks pull the cables taut, lifting the deck.
A suspension system designed to survive ship collisions.
Ensuring commerce in the bay continues uninterrupted.
To the north, the Qingdao section spans 120 meters.
The three legs of the bridge are converging.
Expansion joints are installed to allow the bridge to breathe with heat and cold. As the final gaps remain, the pressure mounts.
The final segment, the closure.
Years of work come down to this moment.
Connection achieved! The bay is conquered!
A continuous ribbon of stone and steel now spans 26 kilometers.
But a concrete beam is not a road. It needs a surface.
Specially modified asphalt is used to withstand the humid, salty air.
Rollers flatten the surface to millimeter perfection.
Six lanes of traffic, plus emergency shoulders.
Beneath the blacktop, a waterproofing membrane protects the structure. Safety barriers are bolted down.
Despite reports of loose bolts, crews work tirelessly to secure every nut.
Thousands of light poles are erected to guide travelers at night.
A complex nervous system of electricity runs the length of the bridge.
The final markings define the lanes.
Surveillance and emergency systems are brought online.
Architectural elements are added, giving the bridge its signature look.
The final cleanup. The construction site becomes a highway.
Engineers perform the final stress tests.
The toll gates are ready to welcome the world.